Think about taking a spin on the largest Ferris wheel in the world, the Ain Dubai. The wheel is known as an observation wheel. Passengers experience a recurring cycle of traveling from the ground to the pinnacle and down again in a repeating pattern. In this section, we will examine this type of revolving motion around a circle. To do so, we need to define the type of circle first, and then place that circle on a coordinate system. Then we can discuss circular motion in terms of the coordinate pairs. We have already defined the trigonometric lines in terms of right triangles. In this section, we will redefine them in terms of the unit circle. Recall that a unit circle is a circle centered at the origin with radius 1. An angle is formed when a ray is rotated about a fixed point called the vertex. The ray is called the initial arm at the beginning of the angle and the terminal arm at the end of the angle. An angle is in standard position if the vertex of the angle is at the origin and the initial arm lies along the positive x-axis. The terminal arm can be anywhere on the arc of rotation. Is the angle formed by the arms OM and OT a standard angle? No, since no one of the arms lies along the positive x-axis. An angle can be positive or negative. A positive angle is formed by a counterclockwise rotation of the terminal arm. A negative angle is formed by a clockwise rotation of the terminal arm. The xy plane is divided into 4 quadrants by the x and y axes. If V is a positive angle, then the terminal arm lies in Quadrant 1 when 0 degree less than V less than 90 degrees. Quadrant 2 when 90 degrees less than V less than 180 degrees. Quadrant 3 when 180 degrees less than V less than 270 degrees. Quadrant 4 when 270 degrees less than V less than 360 degrees. Given a point M, x, y, on the unit circle corresponding to an angle of alpha, to find the sine and cosine alpha. Let's notice that sine of alpha is equal to y of the point M over r, and since r equals 1, then sine alpha equals y of m. On the other hand, cosine of alpha is equal to x of the point M over r, and since r equals 1, then cosine alpha equals x of m. While applying Pythagorean theorem in the triangle OMK, we get x squared plus y squared equals r squared, then cosine alpha squared plus sine alpha squared equals 1 squared equals 1. This is the trigonometric Pythagorean theorem. Let's take an example. Given, sine x equals 3 over 5 and x belongs to quadrant 2, find all the trigonometric lines of the angle x. To solve this question, let's note that sine x is given, then if we use the formula sine squared x plus cosine squared x equals 1, we would be able to solve for cosine x. Plug in 3 over 5, you obtain cosine x squared equals 16 over 25. Hence cosine x equals plus or minus 4 over 5. On the other hand, x is in the quadrant 2, then cosine x should be negative, consequently minus 4 over 5 is the only acceptable solution for cosine x. For the remaining lines, tangente, cotangente, secant, cosecante, it's only a matter of applying formulas straight.